All right, guys. So this is the last section for our exam 2. And we're skipping section 4.6 and we're jumping to section 4.7. So this one is again about inverse functions, but more about their graphs. And yeah, it's a little quicker than the others. So let's get into it. So first we're going to go over some basics. You may remember this from algebra in your previous classes. But first we're going to go into a function. A function is a rule, normally written as f of x. Again, you can also write it as theta, f of t. The f really doesn't have to be f. It can be g, h, or anything like that. But that it pairs each element of the domain with only one element from the range. Okay? So visually, all functions must pass the vertical line test. So sine, cosine, tangent, cotangent, secant, and cosecant are all functions and pass the vertical line test. So if I go to Desmos, I can show you pretty much all the trig functions. Oh, wrong one. Let me write it the other way. Like I jumped ahead. So if I have sine of x, notice that that passes the vertical line test no matter where I drag the line. It only crosses it once. Cosine is the same shape, so that's the same. We go to tangent. Tangent passes the vertical line test. Again, no matter where I drag the line, it only crosses it once. It has a lot of vertical asymptotes, though. All right, and it's okay if it doesn't touch at all. It's still a vertical asymptote. Or, sorry, if the graph doesn't touch the line, it's okay. So on all the vertical asymptotes, it doesn't touch at all, and that's fine. Anyway, cotangent looks the same. And then you have cosecant. And so secant, again, it passes the vertical line test. So all those are functions. They all pass the vertical line test. The way you can think about it is this is what I tell my college algebra classes. Every button, lever, or dial in your car is programmed to do one thing. Okay? So every button in your car does one thing. Every lever in your car does one thing. So you can't push the brakes and sometimes your car stops and sometimes your car, I don't know, opens the trunk. That doesn't happen. Every button is only programmed to do one thing, so therefore it's a function. Anyway, we're not going to focus too much on that. We're going to go more on the one-to-one. A one-to-one function means that in addition to being a function, every y value only has one x value that maps to it. Okay? So that's kind of confusing, so it's better to explain it visually. Visually, all one-to-one functions must pass both the vertical, because it has to be a function, and the horizontal line test. Okay? So sine, cosine, tangent, cotangent, secant, and cosecant, if I go back to Desmos, and you know what, I'm going to pause it so I can create a better graph, because I need to do this a little better. Alrighty. So sine, cosine, tangent, secant, and cosecant, notice that they all pass the vertical line test, like I mentioned earlier. But let me minimize that. There we go. But notice that here's a horizontal line. The blue line's horizontal. Notice that sine fails the horizontal line test. It crosses this horizontal line an infinite number of times. Okay? So anywhere around here, it fails. And again, if it doesn't touch that, it's okay. The horizontal line test means if it touches at least once, it doesn't pass. So sine fails, cosine fails, tangent fails, cotangent fails, secant, it's okay if it doesn't touch, but once you go up here, notice it touches a lot. So that fails, and cosecant fails. So every single one of them fails the horizontal line test. So all these functions are not one-to-one. They all fail the horizontal line test. Okay? So an example for that is, imagine the trunk opening in your car. So imagine you're in your car, okay, and the trunk opens. Do you know exactly which button opened it? All right? Remember, there's the button on your keys that opens the trunk. It's called the key fob. There's the button on the dash. Okay. There's also the what else? The lever inside the trunk. And then also you just have your regular key. Someone could have had the key and manually put it inside and opened it. So there's a lot of buttons that open the trunk. So if the trunk opens and you're just sitting in your car, do you know exactly which of the four methods did it? No, because there's four different buttons that do the same thing. So if this is your y value, the trunk opening, there's four x values that do it. So it's not a one. Your car is not a one-to-one function. And that's good. You don't want your car to be a one-to-one function. You don't want there only to be one way to open the trunk and that's it. You don't want there to be only one way to, I'm not really going anywhere with that analogy. But anyway, so let's go to inverse functions. Inverse functions merely swap the x and y coordinates of a function. So if you had the point on f, if we had the point, let's say 3, 4, then on f inverse, which you would write like that, you would have the point 4, 3. All it does is it swaps the points. Okay? But there's a dilemma, and that dilemma is this one right here. Notice that I have 2 points. I have point 1, and I'm going to make up numbers next to them just so it'll be different. Let's say this is x squared. That's the classic example. Let's say this is negative 2, and this is positive 2. Well, if you square it, both of them give you the answer 4. So for points, you have 2 points. You have negative 2, 4, and you have 2, 4. Well, if we swap negative 2, 4, okay, or if we swap that, which one is the 4 paired with? Is it going to be paired with the 2 or the negative 2? So if I have these 2 points, and notice that if I swap them, which one gets it? I can't do both. I can't say 4, negative 2, and 4, 2, because this is a vertical line, and that doesn't pass the vertical line test. Which means it's not a function. Okay? So that's the dilemma. When you're swapping points, in order to swap it and have everything work out and it still be a function, then it can't be like that, where 2 x values give you the same y value. For an inverse to exist, the function must be one-to-one. I'll write out the letters one-to-one. Now, luckily, the homework doesn't go into the theory of all this, so don't have to worry about too much about it. But sine, cosine, tangent, cotangent, secant, and cosecant So do they have inverses? Okay. Well, we just showed that they're not one-to-one, right? But in chapter 1, way back in the beginning, we were dealing with inverse tangent and inverse cotangent. And basically we were saying that instead of giving the angle and it gives you the value, it gives you the value and the answer is the angle. So we have dealt with inverse trig functions before. So if they're not one-to-one, how does it happen? And that's the big question. So let's go over it. Let's start with sine and inverse sine. Get my notes. All right. So if I start with a regular sine wave, sine goes through 0, 0. At pi over 2, it's 1. Pi at 0, negative 1. And we have just a happy little sine wave. And then 2 pi would be over here. All right? And then here, same thing. So what an inverse does is an inverse swaps the x and the y value. So let's start with some easy ones. This point right here, sorry, my gloves for some reason, I was wearing gloves, they're not working anymore, like they're picking up. Maybe I need to wash them. I don't know. Anyway, so this point right here is pi 0. So if we swap it, that means 0 pi is going to be a point. Okay? We notice that we have another one over here, 2 pi 0. So that means that 0, 2 pi is going to be a point. So all the pi's are points. Now if I go here, actually let's just do this one. This is pi over 2, 1. So if I swap it, it becomes 1 pi over 2. And that really gives me everything I need to make my sine wave. All right? And so all I did was I swapped all the x and y values. Now, again, this is not, why is this not a function? Because it fails the vertical line test. Sine is not a one-to-one function. So if it fails the horizontal line test, the inverse will fail the vertical line test. And so notice I can just draw a vertical line. And notice that it crosses a bunch of times. But anyway, so it's not a function, so we're gonna have to do something we're gonna have to do a little trick. So here's the trick. Going back to Desmos, I want to go ahead, and this is showing that it fails the test. So notice that it fails the vertical line test miserably. So that's not a function. Same thing with cosine. That's not a function. Same thing with tangent. That is definitely not a function. Fail. 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 Okay? So what we do instead is I'm going to go back over here. All right. So what we do instead is we have our sine wave. What we're going to do is we're going to chop off part of the top and part of the bottom until it does pass the vertical line test. So here's my graph. I wish I could hit play, but it won't let me. Play. Anyway, I tried. Okay, so what I'm going to do is I'm going to chop off part of this sine wave on the top. Now we can't chop off all of it because then there'd be nothing left. So instead, I'm going to put in just enough for it to pass the vertical line test. Notice here it still fails. It fails. It fails. So I need to cut off a little bit less. There we go. There we go. And there we have something that works. This portion of the inverse of sine, basically if we flip the x and y values, does pass the test. Now the question is, what is that? Notice it goes from -1 to 1. And as far as y values, if I put these in terms of pi, pi over 2. There you go. Okay, and that's as far as I can go. Again, I can't go any further up because then it fails the vertical line test. I can't go any further down because it fails the vertical line test. So this little sweet spot between -1 and 1 is the only part that works. And then it's a function. So when they say inverse of sine, this is what they're talking about. So it's a very limited function. So we're going to graph it. Okay. Now sine itself is positive, positive, negative, negative. And for our inverse, we want to have a positive and a negative region. So we're going to use these two. Basically, it goes from negative pi over 2. So these are degrees. 0 degrees, pi over 2, pi. And here I'm going to go backwards. So this is negative pi over 2. So the range of the inverse of sine, this is my range, is only from negative pi over 2 to pi over 2. It's not on the left side. So if we're going to graph it, let's see, got these points here, got this point up here. And so the graph, and that's it. The domain for the inverse of sine is -1 to 1. The range is negative pi over 2 to pi over 2. Okay. So again, these are the only x values that you can plug in. Where these are the only y values. So that means that if you have an angle that's on the other side, you're going to have to use reference angles in order for inverse sine to work. And we're going to deal with some examples where that happens. Anyway, let's go to the others real quick. Oh, I forgot. So notation, well, we're already used to doing this. This is y equals sine with the little -1 of x. It's not an exponent. It just means inverse. Okay, or we can say arc sine. Remember that this is not 1 over sine. All right, but anyway, so the meaning is whenever they say arc sine or inverse sine, All it means is the x and y values were flipped. Instead of y equals sine of x, it's x equals sine of y. But only for y's within this range. Okay? And again, the only reason it did that is if y was anywhere past that, it wouldn't be a function anymore. It would fail the vertical line test. So that's why they're limiting what it can be. And Desmos even knows that. So notice here on the graph, I put x equals sine y, and I got this picture. But Desmos knows that there's sine inverse of x. Happen to be the same color, that doesn't help. All right, and so here, let me extend this all the way. Let me extend this all the way down. And we make it a color that's not green. All right, so notice that Desmos does know sine. If you type x equals sine y, it types the whole thing, which is not a function. But if you type in sine inverse of x, that is a function, and it's only this little snippet. Cool? All right. Anyway, just for closure, let me reel this in. Reel that in. Oh, too much. All right. Anyway, let's do cosine. So I'm not going to go as in depth with cosine. Just know that cosine is positive x's. Cosine is related to x values. So if I want a positive and a negative region, I'm not going to do quadrants 1 and 4 like I did for sine. The reason why we did here, we wanted one positive, one negative region. Here, though, I want one positive, one negative region. So I'm going to be doing this part. Again, these are angles, so that's 0, pi over 2, pi, 3 pi over 2. And so everything within this sweep right here is considered to be the domain of inverse cosine. Okay? So if we're dealing with cosine, let's see, what's cosine? It would be, starts at 1, 0, so 0, 1. Okay, so we don't want to keep just this, because notice that if I use these two, it fails the vertical line test. So instead what they do is they use just the one positive, one negative, and so cosine ends up looking like this. Let me kind of erase and start over. Starts there, and then pi negative 1. And then again, notice I can't continue the pattern because it would fail the vertical line test. I can't continue the pattern up here because then it would fail the vertical line test. So the domain for the inverse of cosine is still negative 1 to 1, but the range is 0 to pi. Okay? Or if you're dealing with degrees, you can say 0 to 180 degrees. Same thing up here. If you're dealing with degrees, you can say negative 90 to 90 degrees. It's the same thing. All right, so cosine is y equals cosine inverse of x. Or if that negative one's confusing, you can just say arc cosine. And the meaning is basically the same as before. The x and y just split places, but only for y between 0 and pi. All right, next page. tangent. Again, we want one positive and one negative region. And if I graph tangent, tangent is going to look like this. And it goes on forever in that direction. The dotted lines I gave you are asymptotes. And it goes off forever in that direction. Okay? And this passes both the vertical and the horizontal line tests. And this is going again between negative 90 degrees and 90 degrees. So this is negative pi over 2 to pi over 2. So the domain for inverse tangent is, the domain is everything actually. Notice the arrows go on forever to the left. The arrow goes on forever to the right. The range is negative pi over 2 to pi over 2. Parentheses, not brackets, because it never actually touches. Okay, so again, notation same as before. X equals tangent of y. Oh, sorry, I put that in the wrong spot. The notation is y equals tangent of x, inverse tangent, or y equals arctan of x. And whenever you see that, that just means you swap the x and the y values. And notice I didn't put less than or equal, I just put less than. And that's a y value. All right, anyway, luckily in this section, they don't go over the graphing too much. Here, they're going to focus on more of given problems, how are we going to solve for stuff. So let's start and actually do these problems. And notice that there's not many. I'm going to leave some of them for you to do on your own. So the first is what we did back in chapter 1. It says evaluate in radians without using a calculator or tables. So they're saying sine of negative 1, inverse sine of 1/2. Okay, remember that this is equal to, well, this is saying that sine of what? Equals 1/2. So that's what the inverse means. Right? Now, don't use your calculator. Now, it says don't use tables, but honestly, you can use a table because I use them all the time. But here, you don't need a calculator. I just know that if I'm dealing with this, let me make a table real quick. So you can ignore that table part. I'll allow tables. So 0, pi over 6, pi over 4, pi over 3, pi over 2. We have sine, cosine. And so the answers for these are sine starts at 0, then 1/2, then square root of 2 over 2, square root of 3 over 2, 1, 1, square root of 3 over 2, square root of 2 over 2, 1/2, 0. All right, so where does sine of theta equal 1/2? So you can see that the answer here would be pi over 6. Right? Arc cosine, and again, when you're doing this, make sure that it's within the appropriate range. Remember, the range for this is negative pi over 2 to pi over 2. And pi over 6 is in the range, so we're good. Arc cosine of negative square root of 3 over 2. So here, my range for this one, this is cosine. The range is from 0 to pi. So the answer that I give has to be between 0 and pi. Okay, so negative square root of 3 over 2. Well, for cosine, you can see that there's square root of 3 over 2. And the answer can't be negative, so we can't say negative pi over 6. That's the biggest mistake people will make. They'll say, oh, look, I know that cosine so let me go ahead and draw the thing here. Okay, so I know negative pi over 6 will give me an answer of negative square root of 3 over 2. That's true. But it has to be in the range. And this is not between 0 and pi, which means the answer I give has to be this other angle, where this is the pi over 6, which means the reference angle for that. So I can kind of ignore all of this, because the domain for cosine has to be up here. My answer has to be in the top part. And so if that's pi over 6 down there, then this has to be 5 pi over 6. And so that's the answer. Basically, there's two answers that give you what you want. One answer is going to not be in the range, and the other answer is going to be in the range. So just be sure you pick the one that's within that function's range. So not negative pi over 6, but 5 pi over 6. Okay. Inverse tangent of negative 1. So this is saying tangent of what equals negative 1. Well, I know the range has to be from negative pi over 2 and with parentheses to pi over 2. So if I was going to make an angle, it has to be on this side of the graph, right? And so a negative 1, if I add tangent to my table here, okay, so sine over cosine, 0 over 1 is 0, 1 over 0, undefined. This is 1 over square root of 3, square root of 3 over 3. This is 1, and that's square root of 3. So we have which tangent of what angle gives us negative 1? Well, there's my 1 right here. The angle is pi over 4. So I know it has to be, since it's negative, it has to be down here. Okay, because the tangent of negative pi over 4 is equal to negative 1. So theta, negative pi over 4. And that's within the range. So I'm good to go. Again, for the one above it, cosine of 5 pi over 6 is negative square root of 3 over 2. All right, so those can be a little tricky. Sometimes the answer is really obvious. It just comes straight from the table. But sometimes you gotta have to know whether to tweak it a bit. For the tangent, I knew it was negative, so I knew it had to be down here. For cosine, the answer was also negative, so I knew it couldn't be below it though, because it's not in the range, so it had to be in quadrant 2. All right, so for these next ones, I'm gonna not do all of them, I'm gonna do a couple of them, and then I'll leave y'all to do the rest, but let's start. Evaluate each expression without using a calculator. So in math, it's really easy to see this and be like, oh, look, sine inverse sine cancels out. And usually that's true, but because of the weird domain range thing for trig functions, sometimes it's not. So you have to be careful. So in this case, we already did this one earlier. Sine of theta equals 1/2. We already found out that the theta is pi over 6. So this is the same thing as saying sine of pi over 6, because this is the same as that. And sine of pi over 6 is 1/2. And so here it worked out. Notice the sine and the inverse sine just cancel each other out. And you're left with just 1/2. But that doesn't always happen. So let's move on to this next one. Inverse sine of 135. Okay? Well, if I draw my little thing here, 135, okay, that means that this here is 45 degrees. Sine is positive, positive, negative, negative. So that means that this here is positive, so the sine of 45 degrees is square root of 2 over 2. Okay? But inverse sine of square root of 2, we go to the domain. The domain for inverse has to be in that area. Okay, so my answer can't be the same 135 degrees because it's not in the range of inverse sine. So the answer that gives me square root of 2 of 2 for inverse sine is actually just going to be, let me draw another one, 45 degrees. Because that gives me the square root of 2 over 2 answer that I'm looking for, and it's within the range of inverse sine. So the answer to this is 45 degrees. So notice sine inverse of sine isn't 135, it's just 45. And your calculator won't lie to you. I can make sure it's in degrees real quick. Yep. So I can say sine inverse sine of 135 degrees. And notice it gives me 45 as the answer. All right. Now here, this next one, remember that the domain of inverse sine was just between -1 and 1. 135 is not between -1 and 1. So that doesn't work. This has no solution. Again, I can work it out. If I did sine inverse sine of 135, it says error domain. The number you're entering is not in the domain. So again, just because you see a sine and an inverse sine next to each other doesn't mean you can cancel them out. In the first example, it did work. In the second example, it didn't. In the third example, it just doesn't work at all. Okay? Cosine inverse of cosine of 7 pi over 6. Okay? Working at this one. 7 pi over 6 is over here. The reference angle for that, though, is just this part, which is just pi over 6. Cosine is positive, negative, negative, positive. But notice that the domain for inverse cosine is up here. So since the angle isn't in the range for the inverse, my answer is going to be different. They don't just cancel and it's be 7 pi over 6. Okay? So cosine of pi over 6 is square root of 3 over 2. It's negative, though. And looking at the graph here, cosine, the inverse cosine of, let me make another one, negative square root of 3 over 2. Well, if cosine is going to be negative, it has to be within the proper range. And the only answer that does that is a pi over 6 up here. And so this gives me 5 pi over 6. Okay? Because remember, the reference angles give you the same answer. Since my reference angle was in quadrant 3, I can't use it. So I'm going to have to make the reference angle in quadrant 2, but it's still the same reference angle. And the other angle that results from that is 5 pi over 6. All right? So what I want you to do is work on the other 3. And I'll make a video to finish this off and see how you did. But I want to go on to this next page. I'm going to work on page 5, and you're going to deal with page 6 on your own. All right. So evaluate each expression without a calculator. So here, they're basically saying find sine of theta, where theta is equal to inverse tangent of 3/4. Since I know that x and y swap for inverse, this is the same thing as saying tangent of theta is equal to 3/4. But I know tangent is opposite over adjacent. So that means if I make a triangle, here's theta. Okay. Opposite would be 3. Adjacent would be 4. And this is a 3, 4, 5 triangle. Okay. So you can use a Pythagorean theorem. 3 squared plus 4 squared equals 25. And then the square root of 25 equals 5. Okay. So basically with this, we can create a triangle for theta. And with that, I can finally answer sine of theta. Sine is just opposite over hypotenuse. So sine of theta, opposite is 3, hypotenuse is 5. There's my answer. So these are fun. You're going to see that in the homework, they really like this question. They're going to ask it a lot. And it's a popular test question you see on tests and exams. So let's look at the next one. It says secant of inverse cosine of 1 over square root of 5. So same thing. This is saying secant of theta, where theta equals inverse cosine of 1 over square root of 5. But I know that this is cosine of theta equals 1 over square root of 5. And I can create my triangle. I know cosine is adjacent over hypotenuse. So adjacent is 1. Hypotenuse is square root of 5. So the question is, what does the remaining variable have to be? Well, using the Pythagorean theorem, 1 squared plus something squared equals square root of 5 squared. I can subtract 1. So my missing number has to be 2. You don't have to show the work if you did it in your head, but you do have to show this logic. That you have to create the triangle. You can't just put the answer and be like, I'm done. Anyway, so now I can find secant. And secant is hypotenuse over adjacent. So it's just square root of 5 over 1, which is just square root of 5. Yay! All right, last one. So write the expression sine inverse cosine as an algebraic expression in terms of x only. So this is really popular in calculus. And what they're going to do is exactly the same thing that we just did. What we're looking at here is this is sine of theta where theta is equal to inverse cosine of x. So that means that cosine of theta equals x over 1. I made it a fraction, so I can do SOHCAHTOA. Cosine is adjacent over hypotenuse. Okay, and notice that this is positive. So that means it has to be in quadrant 1. But anyway, so the hypotenuse is always positive. This adjacent means that the x, there were two x's I could have created. If this is the origin, this would have been x, and this is negative x. But since this x here is positive, I know I don't have to worry about the left-hand side. I can just deal with the right-hand side. Anyway, hypotenuse is 1, and so now I can solve for that missing side. So working that out, I have x squared plus that missing sine squared is equal to 1 squared. And I just subtract it over. You know what, I'm going to call it a, as I don't like writing a question mark all the time. So a squared equals 1 minus x squared, and then I can take the square root. Okay, now since this is in the positive y direction, okay, that means that this here is is the square root of 1 minus x squared. Cool, cool. You don't have to put a plus or minus because we're only dealing with quadrant 1. But anyway, so that's my triangle. So now I can find sine of theta. Sine of theta is opposite over hypotenuse. Opposite is, so here's theta. It's the square root of 1 minus x squared over hypotenuse. And so we just finish it off by saying, all right, sine of theta is just the square root of 1 minus x squared. And so that's the hardest one in this section. Good times? Anyway, try the next page. It's examples just like I just did in this page. And let me know how you do. Y'all got this.